Okay, let's look at problem 967. So this is from the book. We're supposed to determine by direct integration the product of inertia, or IXY, with respect to the x and y axes. Okay, so how do we do this all the time? Well, we have IXY is the integral of xy dA, which is lovely. So how have we done this in the past? Well, we will turn around and we'll say, boom, here's a little differential strip. Okay, and the differential strip, the area of that differential strip is base times height. It's a rectangle, right? So the base is dx and the height is y, so I can say y dx. Okay, so now let's come look at here again. This is true. It is absolutely true. That's the definition of IXY. But can we use it? In this case, we cannot use it. So although it's true, it's not helpful. Why is that? Because when we are going from a double integral, remember dA is really a double integral, right? When we're trying to cheat and go from a double integral to a single integral, you have to hold something constant. So in this case, what are we holding constant for this differential strip? Well, we're holding at any point in the strip the x value, how far away it is in this direction, is constant, right? Right now, everywhere along that differential strip, the x is constant. You move it over here and it's still going to be constant. But the y value, whether it be here or here or here, is going to change all over the place. So then you think, I'm smart enough, I can trick the system. I can go with a horizontal strip, right? So now I'm holding my y constant, but the problem is x changes everywhere. So it turns out you cannot draw a strip. It doesn't make sense to draw a strip that holds both x and y constant for dA. So instead, we're going to be smart. We're going to say, hey, you know what? We can outthink this thing. We are going to use the parallel axis theorem on this strip. So we're going to see the IXY of this strip. So dIXY, right? So now again, if I said what is the IXY of that, it's always going to be dIXY bar plus the distance away from the axes that they are. Okay. So where is the centroid of this bad boy? It's right there. Okay. So now, what do we know about this right here? Okay, this is one of the big things that you need to learn from this class. IXY at the centroid is going to be what? It's going to be a big whopping 0, right? Why is it going to be a whopping 0? Because it's symmetric. A rectangle, it's symmetric in both x and y axes through this axis and through this axis. And so it's symmetric, so that goes away. So that makes life really easy. So then we're looking at this term right here. What is the x distance? At any point in time, so dIXY is the x distance from the axis. Well, that's just going to be the x bar of the differential element, right? So this point right here, it's going to be that x bar. And the distance from the x-axis and y is going to be, that's going to be y bar of the differential element. Y bar of the differential element and dA. So let's define these. So again, dA is y dx. X bar of this element is, at any point in time, it's just x. Y bar of this differential element at any point in time is going to be halfway up. It's going to be 1/2 y. So now, if I integrate both sides, I can say IXY is the integral of x bar of this differential element, y bar element, dA. Now that starts to be helpful, right? So IXY is integral, in this case, from 0 to 2a of x 1/2 y times y dx. So it is 1/2 integral of x y squared dx from 0 to 2a. Okay, so now we got to get y in terms of x. So we're going to take this equation, and I'm going to say, therefore, y squared over a squared is equal to 1 minus x squared over 4a squared multiplied by a squared. Y squared is equal to a squared minus 1/4 x squared. So I could take the square root of both sides, but if you look here, I actually need y squared. So let's just plug that in. So therefore, it's 1/2 integral from 0 to 2a of x times a squared minus 1/4 x squared dx. So that is, 1/2 a squared x dx from 0 to 2a minus 1/2 times 1/4 integral from 0 to 2a of x squared dx. No, I lied, that's x squared times x, so that's x cubed dx. Okay, so this is a squared over 2 times x squared over 2 from 0 to 2a minus 1/8 times 1/4 x to the 4th from 0 to 2a. So if you look, 2a squared is 4a squared. 2a quantity squared here is 4a squared. So it ends up being a to the 4th there. And then this 1/8 times 1/4 is 1/32. And 2a quantity to the 4th is 16a to the 4th, so it's 16 over 32a to the 4th, which is 1/2, so this is minus 1/2 a to the 4th. So therefore, IXY is 1/2 a to the 4th. And that is our answer. If I can get that in there. Oh, that was not what I expected. So the key is that this true statement, just not helpful. So this is really the key to these things. When we're doing IXY by direct integration, it's all about doing it this way. And the reason we can do it this way is through the parallel axis theorem right here, and knowing that at this origin, at the IXY bar at the center of mass, at the centroid, the product of inertia is 0 because it is symmetric. And there you go.